perimeter, area and volume. Okay, so your two questions from stuff we've done in the past that will be relevant today are: what is the circumference of a circle of radius 10 centimetres, and what is the missing side on that triangle? First one then, who'd like to talk me through it?
So the circumference equals pi d, which is pi times the diameter. So,
Fantastic, so that's your starting point.
So circumference equals pi times, and you want to times the radius by 2 to get your diameter.
Good, so tricky thing, I've given you the radius, but we need the diameter, so that becomes 20. So 3.14 times 20
is 62.83, and then it goes on, but I just did it to 2 decimal places.
We'll call it 1 then for
Okay.
putting words. There you go, 62.8 centimetres. Everyone happy with that?
Yeah.
How does that apply to what we're doing today? The circumference of the circle is a posh word for the perimeter, isn't it? Distance around the outside. What is the length of x? Anybody managed to find the length of x?
Yeah.
Beth, you want to have a go at that one?
A squared plus b squared equals c squared.
Fantastic. It's almost like you remember what happened last
And then I
week.
put 6 centimetres as a squared.
So a squared is 6
6
squared. Yeah.
squared plus b squared.
Good.
Sorry, I put it b instead of x. And then c equals 10 squared.
Good. So we know that one of the smaller sides, but the important thing is 10 is our, what's the word for it? The long side? Hypotenuse. Good. So 10's our hypotenuse. So we've
6
got.
squared is 36
Yeah.
plus b squared equals 100.
Fantastic.
Take 36 from one side, take it from the other. You're left with 64. Square root b squared, square root 64. And you get b equals 8.
Textbook answer. Absolutely nailed it the way it should be answered. Okay. So how's that going to apply today? Today you're going to learn how to do perimeters of triangles and areas of triangles. If it's a perimeter of a triangle, you need to work it out the distance around the outside. If it was the area of a triangle, you need to know what the base is and the vertical height. So sometimes they'll give you the hypotenuse and you have to work out, like you have there, what the base is. Okay, a perimeter. What's a perimeter?
A perimeter is around the edge.
Yeah, guard the perimeter. Walk around the edge of a shape, okay? So the distance around the outside of the shape. Okay, what units do we measure it in?
Meters.
Meters, centimetres, millimetres, that sort of stuff, yeah? Okay?
Depends how big the shape is, doesn't it?
Yeah, if it was a football pitch, whatever.
Meters.
Yeah. Okay. Basic shapes and perimeters. If I gave you a square, I only need to give you one of the dimensions and you can work out the perimeter, can't you?
Yeah.
Because it's what?
20.
20. You either 5 plus 5 plus 5 plus 5, or you say 4 at 5, which is 20, okay? So it's 20 centimetres around the outside. Rectangle, pretty much the same. 6 plus 2 plus 6 plus 2, if you're walking around. Yeah. 16. Everyone happy with that?
Yeah.
Sometimes not quite so straightforward for something like a triangle. What do we have to do here?
We have to work out what the hypotenuse is.
Yeah.
So it's 3 squared plus 4 squared, so that's 9 plus 16, which is 25, square rooted, 5. So it's another easily identifiable triangle. That's the 3, 4, 5 triangle, and the one that I gave you on your warm-up is 6, 8, 10. You'll start recognising these right-angled triangles after a while. So this is a 3, 4, and that would be 5. So it'd be 5 and 4 is 9, plus 3 is 12. Yeah, 12 millimetres. Good. When you give people perimeters, they go, oh, it's dead easy for basic shapes. So what they can do is combine a basic shape and create an image like that and say to you, in your teams, and write on your white cards, what is the perimeter of that shape, which is made up of 3? Hold up your cards. What have we got? 60, 30, 49...
48.
48, 48. Nice variety of answers. What was step 1 then? Pythagoras, and that missing side is Once you know that's 10, you can orientate your triangles and write down the lengths of the sides. So you know that's 10, you know that's 8. This is 6, but it's in brackets because you don't count it, so it leaves another 2 up there because that's the 8th edge. This is 6 missing here, and that's 4 because that's our hypotenuse. That's 8, and that's 10. So when you add up all the orange colours, you end up with 48.
48.
Okay, posh word for a perimeter of a circle. We've already covered in the warm-up.
Circumference.
Circumference. Circumference of a circle. Anything to do with circles? Pi. So what is the circumference of a circle?
Pythagoras.
Pi times d. Yeah. So the circumference of a circle is pi times the diameter. Another one, just for Ali.
Okay.
You've got a piece of pie, you cut into 8 pieces, and you put your pieces down into this shape. What is the perimeter of that shape? Everybody understand what I mean by perimeter on this one?
20.
What is the perimeter of that shape? I'm giving you a clue. I'll put it in red.
3.14 times 20.
3.14 times
The diameter, which is
20, which is
62.8. Yep, that's where I was up to. I'm not sure of the next step.
so what does that give us with respect to our perimeter?
The circumference.
It gives us circumference, it gives us these 8
All the
parts here.
arches.
Those arches, as Ali says. Okay?
Plus 20, which is 82.8.
Plus 2 radius, and 2 radius is equivalent to
Diameter.
the diameter. So plus the 20 gives you 82.8. Okay?
Yeah.
So sometimes in the exam they might not give you a square or a rectangle and ask you for a perimeter. They can ask you nasty questions like that, which involve a bit of lateral thinking. Is that you, Molly? Regular polygons. What's a regular polygon? What's regular?
Sides are the same.
All the sides are the same length. Polygon,
5 sides.
lots of sides and shapes. So here I've got what shape? Pentagon. If I said that's 5, what's the perimeter of the pentagon?
5 times whatever the...
If I said what shape's this?
Hexagon.
It's got 6 sides and it's 6 each. And this shape is a...
Octagon.
No.
Septagon.
What shape is it?
Octagon.
It's an octagon, and if each side is 7,
7, it's septagon
56.
that, isn't it?
it's got 8 sides. It's called an octagon. And I've confused you by writing the number 7 down for the length.
Why did you... Oh, that, sorry.
So 7/8 are 56 centimetres for that one, okay? They can't give you anything too difficult with those other than the length of one of the sides. You don't have the skills at foundation level, you don't need the skills at foundation level to work on complicated polygons, okay? So don't worry about that. But this is what they can do to you. A hexagon has a perimeter of 24 centimetres. We put 3 of them together. What's the perimeter of that new shape? Everyone get
Yeah,
48?
Yeah.
How do we get 48?
Because the perimeter is 24, so you divide it by 6 sides.
Gives you
4.
4 per side.
And then you just... there's 12 sides.
Yeah.
So 4 times 12.
12 sides.
Yeah.
Happy?
Bish, bash, bosh.
Bish, bash, bosh. Okay? So despite perimeters being an easy subject, they can try and catch you out. We're now going to look at perimeters of complex shapes. There is a process for doing complex shapes, and it's in 2 stages. Stage 1 is when you're given the measurements, fill in any gaps that they don't give you. And step 2 is pick a start point and literally walk around your perimeter. So, on this shape here, there's some gaps. What numbers can I fill in on there?
8 and 2.
Where's the 8?
Across the top.
So 8 is missing across the top.
2 up the side of the 4, and that leaves 5.
So the 2 goes there. How did you get that?
Because the top
So 5 and 1 is 6 with vertical height, and we know the total vertical height is 8, so 8 minus the 6 gave us that 2.
That makes the other one 5. The invisible one.
This one?
No.
No,
No,
the
that's
one
4.
down.
Oh, this thing?
Yeah.
You
Well,
don't need
that's
that though, do you?
Don't need it. We're not going to walk around there, but I understand what you're saying. And one more.
4.
That's
4. Okay. So that's step 1. Fill in the gaps so you understand what's missing. Step 2, pick a start point. And this is advice for the exam. I know it's a calculator exam, so don't just tap in the numbers and write an answer down. Is show the examiner what you're doing. So we start in here and we're walking around. Yeah? That is my advice to you. And then you don't miss anything. Then you don't just put it in the calculator and put down the wrong number. If you do that, then add it up, put it equal to whatever it is, 9, 11, 19, 27, 35, 36, 40. That's the way to do it. Okay? So fill in any gaps so you know any missing measurements, and then pick a start point, walk yourself around and write down the numbers as you walk around, and it will save you missing anything. Okay. Other complicated shapes. If I gave you a complicated shape, treat it as 2 shapes. Okay.
You would split it, would you, into a square and a semicircle?
Yeah, so if we put a dotted line there, we know we've got a square and a semicircle, but we're trying to find the perimeter.
Yeah.
So
So you-
same rule applies, fill in the blanks.
Yeah,
So
so you
2
put
across
2
there.
there and 3 where the dotted line is.
But we don't need that one, but
I
you're
know,
right.
but you need
yeah.
the number. So that's
Yeah.
your diameter, but you want to work out the circumference now.
Yeah,
So then you can halve the circumference.
good. So circumference is
pi
times the diameter. 3.14 times,
3.
which is,
And then half it. And then that's your answer. Okay, well done.
4.7.
so now what's my perimeter? Step 2, pick a start point and write it down. Yeah, and then you don't miss anything. 3, 4, 5, 6, 7, 11, 7. Yeah. Happy?
Yeah.
Good. What I will do is show you the last bit. This is the C grade stuff as far as perimeter area and volume is concerned. Okay? They can introduce algebra into perimeters and areas if they want to. They're quite fond of it with perimeters because when you do it with areas and volume, you end up with square numbers and cubes of these, and you don't need the skills to do that sort of thing. But what they will do is stuff like this. So what is the perimeter of that rectangle?
Is it 8x?
How did you get that?
Because I'm thinking 3x and 3x at the top.
Good, so
And
we're
then-
doing what we normally do,
yeah,
we're filling in the
yeah.
blanks, and then if we
And
wrote
I
it
just
down
add them up, yeah,
by
add them
walking
up.
around, I've got x plus 3x plus
Plus
x
x.
plus 3x.
X.
So we're doing exactly the same process as we did before, but instead of having numbers, we've now got letters. And as Judith's quite correct, these are the same terms. These
Didn't say that.
These are all the correct terms, so they're all the same terms. So when we go back to week 4, when we did basic algebra, you can add these together. So an x plus 3x is 4x, 5x, Judith's perfectly correct, 8x.
Good job.
With opposite terms.
Sorry?
Are they like you to give you one with opposite terms on perimeter?
The next question coming up is not opposite terms, but different terms. That's just about to come up. Okay? So this is step 1 generally. And then what they will do in step 2 is they will say, if Bob has got, 48 metres of fencing, how big is X? So basically he's planned his garden and his garden's going to look like that, and he's got 48 metres of fencing. What is the value of X? And what we're saying is
Divide it.
48, yes, what do we divide it by? To get X on its own,
Take away.
8 on both sides.
so 6 eighths of 48 is equal to X. So X would be 6 metres along there and 18 metres along the length. You see what we've done?
Yeah.
So they'll give you an algebra type perimeter,
28.
and then they'll give you some values to substitute in or solve it. Does that make sense? And that's kind of the hardest perimeter question you can get. Guess what's coming next? One for you to do. So there you go. We were talking about terms, different terms. So there's a shape. Don't care what the shape is. What is the perimeter in terms of x and y? And if the perimeter is 32 centimetres and x is 5, what is the value of y? Let's go through it then. Let's walk around the first time. What should we go for first time? What should we collect? X's or Y's? X. Let's collect the X. Okay. How many X's have we got?
X plus 2x.
So we've got X plus 2x plus
X.
Another X gives us
4x.
We've got 4 X's. Let's go around and do the Y's.
Y plus y plus 2y plus 2y.
6 equals 6y.
And when we put them together, we get
4x plus 6y.
So that's question part 1 answered.
Yeah.
Part 2 then. Anybody like to tell me what I need to write down to solve this?
Sure. Go on then, you go.
Go on then, Jim. No swear words on recording
X
this.
is 5 centimetres.
So if X is 5 centimetres,
And we know we've got 4 x's, so 4 times 5 is 20. So then you take the 32 minus the 20, leaves you 12.
okay, so it would look something like 20 plus 6y equals 32. That's essentially what you're saying. So we've made an equation out of this. That's the important part, okay? And we've substituted the x for 5 and it's given us 20. So we're now looking at 20 plus 6y equals 32. So what Julia's now saying is we're going to solve this by taking away 20 on both sides. Leaves us with 6y equals
12.
12. And then divide it by the 6.
and then y is equal
Which
to
gives 2.
Perfect. Everyone happy with that?
Yeah.
So, a bit of perimeters, a bit of algebra, a bit of two-step equations, a little bit of everything. Okay.
Just to confuse us.
Did I confuse you? Oh. Okay, I've got a worksheet for each of our topics today. If you just do the first part of the first question on this worksheet, which is the perimeter of this room, go and buy some skirts.
Why 1.6?
Well, I've done 6.10 plus 5 plus 4.5. I've got the 2.25 and then this bit here, I need to do 2.5.
I know, but all I've done is add those together.
Added all them up.
So I've done 5.
Yeah, instead. Yeah, I get what you've
But I've missed one of them.
I think you have got what for. You have missed one off for 2.5.
Yeah.
Yeah.
Just question 1. Or moving on.
You can move on if you've finished it, if you feel comfortable.
Right, so okay.
Everyone get 22.2 for the first one.
23
Yes?
is
No?
It's giving me 23.
I got 22.2.
22.2.
Yeah.
You got what? Sorry.
25.2.
Oh, wait a minute.
Yes? No? No?
Just doing it now.
I'll just cover the second one because it is slightly more complicated for those of you who have attempted it. Okay. Anybody trying the second one? We'll go through it slow time just to check your answers. What do we need to do on this then? We need to go round twice. First time we go round, we're going to deal with what?
X's.
The x's. So if I start here, what have I got?
2x. 5x. Plus 2x. Minus 3x.
Minus 3x. Don't forget to take the sign that's in front of it. So I've got 5, 6, 7, 9 x's minus 3 x's leaves me. The second time I go round, I'm going to do the what?
Get the numbers.
The numbers. Good. We haven't got y's but numbers. So I've got 1 plus. So that's 1, 2, 3 plus 29. 32.
Yeah.
Put them together. And that's what the perimeter is. That's what it's saying. Can't solve it because I haven't given you a value for P. So for that second one, looks tricky, but it isn't. If you keep your wits about you and do the basic algebra, go around twice, do the letters first and then the numbers, you end up with 6 x's and 32. You put them together to create the perimeter. Okay, and that's all that was about. Good. So that's perimeters done. Everyone happy with perimeters?
Yeah.
Good. Just going to spend 5-10 minutes before the break touching on areas. I want to get into a discussion on areas, okay? What is an area? The bit in the middle. Oh, I do like that. Yeah, the bit in the middle. It's basically the space inside a two-dimensional shape, okay? What do we measure area in? Centimetre squared, millimetre squared, metre squared, that sort of stuff, okay? That's what we're going to use as our units for area. So let's look at our basic shapes then. Everyone goes, oh, I know this. What is the area of a square? If I say this is a length A, what's the area of that square?
4A.
A times B.
A times A, because it's got the same length, so A times A is, somebody said it, A squared. Good. That's what Pythagoras was all about last week. It was about creating squares on each of the sides, wasn't it? Okay? So the area of a square is its length multiplied by itself. So you just square whatever the length is to work out the area. Anybody tell me the area of a rectangle then?
A times B.
Yeah. If we had A and B, we would multiply A times B. Here it's the breadth times the height. It's written in lots of different ways, but basically it's whatever that length is multiplied by that length. That gives you the area of a rectangle. What about a triangle? A times B times C.
And half.
Half.
Base times.
Yeah.
Good. Because a triangle is half a square, so we had A times B, or we call this height and base, whichever way around you want to do it. It's the half of the base times the height, which is in there. Let's swap those out. So the area of a triangle is half of the base times the height, because it is half the area of a full square. This is a nice easy triangle to do because
It's a right angle.
it's a right angle and the
So-
height is there and the base is there and they're dead easy to work out. What did we do last week as an exercise when we had a nasty triangle like that?
We had to work out
Height.
what the middle was.
Yeah, it's the vertical height. And that's the important thing with this equation, is it's talking about the vertical height. So work out the vertical height, drop a line down from that centre line to create two right angle triangles, and it allows you to work out H. Yeah?
Sure.
And we did a couple of those last week. You might get one again today. Okay. So the last thing we're going to do before the break is we're going to have a discussion on basic perimeters and areas. Okay. I want you to draw two rectangles, and it's making an assumption here. The one with the greater area will also have the greater perimeter. Is that always true, sometimes true, or never true? Okay, we're going to talk about areas of circles, which we did the other day. We know areas on circles have got something to do with pi. Okay, so what's the area of a circle?
The area of a circle
Pi r.
is...
Is it pi r squared?
Good, yeah.
That's the only one I can remember.
Well, if you can remember that one, then the other one should come to you. There's only two things on a circle you should know. circumference is pi times d, and the area of a circle is pi r squared. And we practiced that quite a bit when we did circles, or the basics of that. You happy with that?
Yeah.
So you ready for this next challenge?
Yeah.
Pete's Pizzas. Okay? Normally, I'll order a 14-inch pizza for a tenner. This week at Pete's Pizzas, we've got a deal where you can have 3 7-inch pizzas for a tenner. I've got £10 in my pocket, and I want to get as much pizza as I can for my tenner. Which pizza should I buy? Not big orderers of pizzas.
No.
Not the best colour, is it?
40.
Everyone had a go at that? Everyone come up with an answer. What would you order?
14 inch.
14 inch.
14 inch.
Let's do the numbers. Let's do it with maths. The large pizza then, area-wise. How do I work out the area of my large pizza?
3.14 times 49.
So it's 3.14 times 49, because the radius is half the diameter, so it's 7. So 3.14 times 49 gives me how much pizza?
153.86.
Inches squared. Okay? So we've got 153 square inches of pure Saturday night joy. Let's have a look at our 7-inch pizza. What's the area?
3.14 times 12.25.
Times, and it's 3.5 squared, which is 3.14 times, what did you say, 12?
0.25.
Which gives me an area of pizza of
38.48.
38.48,
Times
which is
3.
times 3, because I've got 3 pizzas.
115.45.
115 inches square. You wonder how these pizza people make money.
Yeah.
It's almost a third smaller for those 3 pizzas. Third less dough, a third less toppings. Yeah? Okay, parallelograms. Parallelogram is essentially a square on its side or a rectangle on its side. So what you're essentially doing is you're taking this triangle, moving it over there, and saying we're multiplying the base by the height. But it's the height that's the tricky thing. That little V there means the vertical height. In other words, from the base to the top. How would I work out that vertical height if they don't give it to me?
Would you do the same as...
Is it like what
A
we do with
plus
the
B equals
hypotenuse
C.
stuff?
Yeah, it's like a triangle, isn't it?
I could work out the vertical height from that corner to the base, providing I have enough measurements to do that, and using Pythagoras, I could calculate that height. So always think about how could you use Pythagoras to get that. Okay? So that means they'd have to give you that length and that length to allow you to calculate this length. The next one, the trapezium, you have to add your lengths on your top and your bottom together and work out the average. So add A and B and divide by 2. That's what all that nonsense is about. It's saying I add A and B together, I divide by 2, and then I work kind of an average out for those 2 lengths. And when you've done that, the rest of it is exactly like the parallelogram, where you need a vertical height. Either they'll give it to you, or you can calculate it by using Pythagoras. Okay. I've got an asterisk on a trapezium because on a foundation paper, on the inside page, so that's your front page, the first page as you turn over into your exam is this, and it tells you how to work out the area of a trapezium. Okay. Now, this is not a question. I have in the past on practice papers had people trying to solve these two. They're not questions. They are formula for you to refer to. Okay? They are there to help you out in the exam. What's worse is the one and only exam paper I have found with a trapezium in, they actually gave this again. They give you the formula for a trapezium. So this isn't something for you to first solve when you open your Unit 3 paper. That is a reference for you. Okay? So you don't have to remember this because it's on the inside of your paper. If you do have to use it in the paper, 9 times out of 10 they give it to you again. So why have they put it there? I just don't understand. Okay? So let's have a look at some areas of complex shapes. How do we solve an area for a complex shape? Good, everyone's doing a bit of that. Okay.
Break it down.
Break it down. Excellent. So if I've got 3 by 2, I can work out the area of my archway door.
Yeah.
Because the area of the rectangle is
3. 2 times 3, which is 6.
6 metres squared, and the area of my archway,
Well, you need to work out the circumference.
Well, wouldn't
we're working on areas.
you do pi r squared and then half split it up? Times by 3
3 is it?
squared.
No,
That's
the
not
radius
1.5.
is 1.5
Oh yeah.
times squared. Sorry.
See what we've done there?
Yeah.
Remember, radius, diameter. Think long and hard about which one you're going to put in there. Okay? They've given you the diameter, so you have to work out the radius. So I've got 3.14 times 1.5 squared, which is
7.065.
7 will do. 7 metres squared. So we put 7 in there. The area of our whole thing, yeah, 6 for my rectangle. Oh, it's half of that 7, isn't it? Sorry, nobody corrected me there. So 7 metres squared would be for a full circle, but we haven't got a full circle, have we? We've got half a circle. So you need to divide by 2 to get 3.5. See my mistake?
Yeah.
It was deliberate, nobody corrected me, we've all failed. Okay, so I've got 3.5 there. So the area for the whole thing is 9.5 metres squared. Yeah? So break complex shapes into 2 basic shapes. That's the way to tackle areas. So I think in your last homework there was like an L shape that you had to solve. So just break it into 2 rectangles. Squares. If I have an area for a square, how do I calculate the length of each side of the square?
Square root.
Good. You square root it. Okay, so if I said this is 40 and I square root 40, then I know this is 6.3 and this is 6.3. That's what Pythagoras was all about, but some people lose that perspective when they're in the exam given an area of a square. They then can't work out the area of each of the sides. Okay, good. Let's work on the C grade stuff then. Okay, if you're given a rectangle, a square, a triangle with letters, what do you have to do to work out the area of that rectangle?
X times 3 times
X times
3x.
times 3x. What's x times 3x?
3x squared.
Good. 3x squared. All they'll do after that is they'll give you a number to substitute in there. They can't ask you to solve anything like they did with perimeters, because that was only x to the power of 1. With x squareds, you're not expected to manipulate them. So all they can say at this stage is say, if x is 5 metres, then what is the area of that rectangle? So what does that become?
3 pi
3
squared.
times 5 squared. Sorry.
Good.
3 times 7.
Whatever the units are. Okay? So that's all they can do as the next step on an algebra question. They can't do like we did with perimeters and say, oh, it's equal to something, and then you can manipulate things. You're not required to manipulate stuff as hard as that at foundation level. Okay? But they can ask you to substitute a value into there. So in this instance we put 5 in there, so you substituted 5 and you came out with an area of 75 metres squared. Good. Okay. I'll give you 10 minutes on the areas worksheet and then we'll do work out the area of the room. So we'll have a talk through it. Okay. Has everyone done the first bit with the image?
No, but I think we've got it wrong, so I need to go through.
We'll go through it. Right, if you listen up, we're going to go through that first image. Some of you are addressing it in the wrong way, trying to apply Pythagoras when you don't need to, okay? Let's have a look at it. What 2 shapes have we got?
Square and a triangle.
Sort of rectangle and a triangle. So if we do our rectangle first, what's the area of our rectangle?
I've just got it already.
50 times 40 gives me 2,000 centimetres squared. So that's 2,000. So that leaves our triangle. Now you don't need to apply Pythagoras this time because all you need is the base and the height of a triangle. And in this instance, you don't have to calculate it because you know the height is 50 and you know the base is 15. So to work out the blue area of our triangle, it's half of the base times the height, which is 7.5, times 50, which is 375.
Yeah.
Add the 2,000 from your rectangle, and you have 2,375 centimetres squared. Let's move on to the final bit then. Let's do volumes. Matt,
I'm really confused here.
with what?
Yeah.
You've worked out the area of the floor in centimetres squared. So the width of the room is 6.9 metres, which is 698 centimetres. And you've multiplied it by 9.3 metres, which is 930 centimetres, and you've got 649,140 centimetres squared as the area of the floor.
Right.
You've also done the same for the Mars bar. So the Mars bar is 10.4 centimetres long and 2.8 centimetres wide. So when you multiply that by that, the surface area of a Mars bar is 29.12 centimetres. What we're going to finish off with to do that is volume. So we're going to have to multiply it by that third dimension. And that's how I want you to see volume, is a two-dimensional object that has space behind it. Okay, so volume is what? Can you remember what we called it before?
Is it length?
Is it how much?
Length, breadth, and height?
Good, so it's 3 dimensions and it's...
Is it cubed?
It is
Not
cubed.
how much is in there.
Good, it's how much is in it. So, essentially, volume is the quantity of 3-dimensional space enclosed by a boundary. So we're going to find out how much space there is in a cube and a prism and stuff like that. But we're going to do it in a very formatted way. What units do we use? How do we know that something's cubed? Because it's the 3, if you think of it as the 3 dimensions, or a dimension multiplied 3 times to get it. So you work out the area and then add that third dimension. So it's millimetres cubed, centimetres cubed, and metres cubed. They're the dimensions that we're going to use, okay? So let's have a look at 3-dimensional shapes then. All I want you to do is take the knowledge you've just got from working out areas and work out the area of something and multiply it by the depth. So you don't have to remember width times length times breadth. Forget that. Think about your 2-dimensional object and how to get the area of a 2-dimensional object and just multiply it by that third dimension. So what shape is that then? What 3-dimensional shape? It's a cube. So if I say that's 5 centimetres, the orange area is what?
5 centimetres. Oh.
Yeah. 25. It's 5 times 5 because we know it's a square. So if it's a cuboid, that third dimension is what?
5.
So it becomes 25 times 5. So 25 times 5 gives us 125 centimetres cubed. So can you see how it works? All you need to be able to do is work out the area of the 2-dimensional object and multiply by whatever's behind it. Okay? So let's look at this shape, which is a cuboid. So the basic shape that's facing you is a rectangle. So let's make up some values. It's 2 by 4. So that orange area that's facing us is 8. And if I say it's 3 deep,
8 times 3.
24 centimetres cubed. Good. Let's do it for this object. Okay. It's a, what's the shape? Cylinder. It's a cylinder, so the basic shape is a circle with something behind it. So if I said the circle has a radius of 10 centimetres, what's the area of the circle? Pi times 10 squared. 3.14 times 100, which is
314.
good. And if this is 10 centimetres deep,
Times 10.
3140 centimetres cubed. So all you need to do is work out the area of the two-dimensional shape and multiply it by the third dimension. So a prism, and this is a triangular prism, okay, is essentially a triangle with something behind it. Yeah? Happy with that concept? And that's all we're going to do. We're going to practice each of those, okay? So let's start off with a cube or a cuboid. Look at the two-dimensional basic shape that's facing you. In this case, it's a rectangle. And then just multiply it by that third dimension. You don't have to remember things like this. All you have to remember is how do I calculate the area for a rectangle or a square, and then multiply it by whatever's behind it. Don't forget the units, cubed. And in this paper, Unit 3, they will ask you for the units. They'll just say answer ... And they won't put millimetres cubed, centimetres cubed, metres cubed. You're expected to write them in. So that's an extra mark for these in these papers, if it's not there. The other way they do three-dimensional shapes to work out the volume is they like playing around with these cubes, which we will do in 2 weeks' time when we do 2D representation of 3D shapes. So if they give you a centimetre by centimetre by centimetre cubed, the volume of one cube is 1 centimetre cubed. So in order to work out the volume of that, you just count the squares. 1, 2, 3, 4, 5, 6 centimetres cubed. And so you will come across them, and we'll use them next in 2 weeks' time. Okay? But for now, I'd like you to tell me the volume of those two cuboids. Okay? So do the basics, look at the basic two-dimensional shape, and just multiply it by the third dimension. So the area of the basic 2D shape that's facing you, and then multiply it by the depth. So the basic thing that jumps out of this one is this area here. So calculate that area and then multiply it by whatever's behind it. See what we're doing? That makes sense. And do the same for the other. Okay, give you a couple of minutes to do both. Right. Let's see if we've had a go. Lefties. Talk to me, lefties. This first image then, how would we break that one down? Good. 10 times?
15.
So this blue area here
10 times 15.
is 10 times 15 is the best way to approach it. So do the basic 2D shape that's facing you. 10 times 15.
150.
150 centimetres squared.
Times that by the 4.
You're right at the back?
Yes.
So we work out the basic two-dimensional shape that's facing us, the area of it, and then multiply it by the 4, gives us
600 centimetres.
600
cubed.
centimetres cubed. Good. So this one, righties. Autumn and Laura. Do you want to? Yep.
1.83 metres
1.83.
times 1.9.
Good. So this basic square that's facing us is 1.8 by 1.9, which is
3.47.
3.47. And then you're going to multiply that by
1.7.
the third dimension, 1.7, giving
5.9.
Sorry?
5.9.
5.9. 5.9. And it is metres cubed, because it's a volume. Yeah? Happy with that?
Yeah.
So we're going to use that same process for all of our shapes. So the cylinder, okay, has a basic shape of a circle with something behind it. So to work out the volume of a cylinder, just work out the area of your circle and just multiply it by the depth. Okay, so there you go, 2 for you to try.
No, it's just gone blank now.
Yeah, I am, but it's gone.
No. You're working out the area of a circle, so here's your circle, and it's got a diameter of 8. Hey! Centre backs, talk to me.
Right. Okay, so we know it's pi r squared, so it's 3.14 times 4 squared, which is 16.
Good.
Okay, which equals 50.14.
Good. So that's the area of our red circle at the top.
Then you times it by 9.
Yeah.
Which gives you 452.16 centimetres cubed.
Super. Everyone get that?
I've got
No, it's
0.2.
I got it wrong.
50.25.
That's what I've got.
I got
50.25
times
9.
times 9, yeah, which is 452.
Times 16. Yes, my mistake.
Is
It is 452.
I obviously glanced at the calculator display.
okay.
Anyway,
So-
centimetres
right.
cubed.
Don't worry about rounding and being point something off. You get a plus or minus correction on these things, okay? Because the examiner knows that if you round one of these up, as the number gets bigger, as you keep multiplying things, then his amount of error will give you plus or minus 10 at this point, plus or minus 1 or 2 at this point, okay? So you don't have to be mega pedantic with those decimals. So you can be 0.1 off or 0.2 off, you know? So don't worry too much about that. There is leeway within the marking schedule. Okay, centre forwards. Do you want to do the one on the right for me?
3.14 times 3 squared. So 3.14 times 9, which is 28.26. Times 6, which equals 169.56 metres cubed.
Everyone get that? Good. So it's a basic two-dimensional shape. There's something behind it. There's nothing too volumed, yeah? If you just keep your wits about you. So here you go, a triangular prism. We know the area of a triangle because it's
Half base times.
half the base times the height. Excellent. Okay. So there's 2 prisms for you to do. Who would have thought at the start of this lesson you would have been calculating the volume of a triangular prism? Want to do this one for me, lefties? Go on then, Ems. You look like you're going to talk to me. Talk to me, Ems. 5 times 10. So half the base times the height is 50 centimetres squared for that lovely triangle. Good?
Times it by 25.
Times by 25, so our depth.
1,250 centimetres cubed.
Superb. Happy with that? It's not magic, is it? Okay, this one? Centre rights. Oh, sorry, right backs. Right forwards. Right.
16 metres,
16
times 6,
times 6 gives us
96.
96 metres squared for the area of our triangle. Times 10. 960 metres cubed.
Yeah.
Okay, good. If you get complex shapes, do not panic. It's all about the areas. The depth is irrelevant. The depth is the thing you do at the end, and that's what you multiply it by at the end. So if you get a complicated triangle where you haven't got a lovely height, how would I calculate the height of that triangle? You create a right-angled triangle, and using Pythagoras with the hypotenuse and 2 centimetres as your base, you can calculate the height to work out the blue area. Yeah? Okay. So that's that, and then you would multiply it by the depth. If you get something that looks like this...
Will you do that one for us? Just do it,
sure.
please.
Okay. So the hypotenuse is 7. So that's C, isn't it? So 7 squared is the hypotenuse. If we make this A squared, so that's 2, isn't it? Because the whole thing is 4.
Yeah.
It's 2 squared plus B squared, if we call in the height, B, equals 7 squared. So 2 squared is 4, plus, we'll call it the height now, height squared is equal to 49. How do I get the height on its side? Minus the 4. Height squared equals 45. Square root of 45 is our height. So what's the square root of 45?
6.7.
6.7. Yeah? Happy with that?
Times
So our height is
by 12.
6.7. So The area of our triangle in blue is half the base, which is 4 at the moment, times the height, which is 6.7. So it becomes 2 times 6.7, which is 13.4. So the area of that triangle is 13.4. Can you see how we got that? Yeah?
And then times that by 12.
And then times that by 12
Right.
gives you 100.
157.68.
5.68 centimetres.
No,
got 160.8.
160.8.
Oh, I've got a 1 in there, sorry, I've not put it in. I've put it in proper. That would help, wouldn't it?
Okay. So it's 13.4 times 12 gives you 160.8. You're happy with that one? So that's the.
I like that one.
No, I don't like that one.
But I reckon you just do the
I reckon the one on the
rectangle
right
and
is
square.
easier. Sorry?
Yeah. Just breaking it down into
Yeah.
two rectangles and a square.
Good. So how would you? Which way would you put the lines? Horizontal or vertical?
Well, I would go vertical. Oh, well,
Horizontal.
yeah.
That way? Doesn't matter. It gives you
yeah.
the same answer. So now it's just like we did before. We're working out the area of 3 shapes that are
Yeah.
stuck together. So let's look at the basic one.
So 20 times
20
11.
times 8, is it now?
Yeah. So it's 8 up to there, and that's
Oh,
another
yeah.
3. So 28.
Yeah.
160 for our green area. Does that
Yeah.
make sense?
Yeah.
What have we got here? 3 times, which is 9.
Yeah.
That's our blue area, and then our red area up
4
here.
times 3.
4 times 3, which is 12. So the 2-dimensional shape that is facing us has an area of 160 plus 9 plus 12, which is 170, 181 centimetres squared. Can you see that?
And then
Yeah.
times that by 25, do you though?
Oh, suddenly we're all experts. Times 25 would give us our volume, which is what? I haven't got a calculator. 181 times 25.
I don't know, do it over.
4525.
4525.
25.
Yeah, I get that. But
Centimetres. I bet you did.
I didn't put a 1 in this time.
Can you see how we did that? So what looks like a really, really complicated shape isn't that difficult because it's just the area of the 2-dimensional shape with something behind it. If they give you something really nasty in the exam and they say, here's a blob, and the blob has got an area, Pete's new sweet, it's my new variation on rock, okay? And this area is 10 centimetres squared, and my rock goes back 20 centimetres. You don't care how I've got that 10 centimetres. How do you calculate the volume?
10 times
Good.
20.
It's the area of this, 10, times the 20 depth is 200 centimetres cubed is the volume of my piece of rock. You don't care. If they give you that area, they've done that for you. You can't calculate it any other way. Okay? I'll give you a worksheet. You should be able to do all the questions on the worksheet in 10 minutes. Now, that is today's lesson objectives. Okay? We've done perimeter, we've done area, and we've done volume. Hopefully you've seen now that perimeter isn't as simple as just adding up the lengths of the sides. You might need to think a bit deeper